The speed of fast-moving neutrons in a nuclear reactor can be reduced by using dash. The correct answer is definitely A. Remember, in a nuclear reactor, there is a substance called a moderator. What does a moderator do? It helps to moderate. To moderate means to slow down fast-moving neutron. And an example of a substance used as a moderator in a nuclear reactor is a graphite rod. Not only that, we also make use of deuterium or heavy water as a moderator. Now, don't be confused. A moderator is different from a control rod. Whereas a moderator is used in slowing down fast-moving neutron, a control rod is used in absorbing all these fast-moving neutrons. So, an example of a moderator is graphite rod. Another example is deuterium or heavy water. Whereas control rod, you have example of materials used as control rod as cadmium and boron rod. So the correct answer here is option A. Let's go to number 22. In a series that's talking about resistor, inductor, and capacitor circuit at resonance, impedance is dash. Now, at resonance, impedance is always minimum. So the correct answer is option B. Don't forget that in an AC circuit, when an AC circuit is at resonance, it means that the inductive reactance XL is equal to the capacitive reactance XC. Don't forget that the impedance, which is Z, capital letter Z, is minimum and the current is maximum. But the question is asking us what happens to the impedance here. Impedance is minimum. If the question is asking what happens to the current, current is maximum. So the correct answer is option B. Let's go to number 23. A lamp is rated 240 volts and 60 watts. We are to calculate or determine the resistance of the lamp when lit. So let's look at the board. The voltage is 240 V and the power is 60 watts. Don't forget there is a simple formula that connects the voltage, the power, and the resistance all together. And the formula goes thus. The power is equal to V squared all over R. Now, we can simply make our R the same formula. When we do that, R becomes V squared all over P. And that becomes V. We'll be given the volt 240, that's 240 squared, divided by the power, which is 60. Here, don't forget the unit of resistance is ohms. So, the resistor now is, using our calculator, 240 squared, 240 squared gives us 57600 divided by 60 ohms. And when we divide by 60, then we get 960 ohms. 960 ohms. That is the correct answer. And if you look at the option, that is option D. So for number 23, the correct option is D. Number 24. One major reason why electrical appliances in homes are normally earth is that, as a matter of fact, the major reason why electrical appliances in homes are normally earth is to prevent cases of electric shock. That is definitely option A. A person touching the appliance is safe from electrical shock. So that is the major reason why electrical appliances in the house are normally earth, to prevent people touching the electrical appliances from electric shock. That is the correct answer, option A. Let's go to number 25, please. In doping an intrinsic semiconductor to produce a p-type semiconductor, A, the semiconductor is heated up. It is not necessary. B, a donor element is added. That is the correct answer. We want to dope. And what is doping? Doping is the process whereby small amount of impurities are added to pure semiconductor like silicon to increase their conductivity. That is what doping is about. During doping process, we can produce a p-type semiconductor if a trivalent metal is added, or an n-type semiconductor if a pentavalent element is added. So the correct answer here is option B, a donor element. Either a trivalent donor element is added or a pentavalent donor element is added. The correct answer is option B. Let's go to number 26. We are to arrange the following radiations, alpha, gamma, and beta. We are to arrange them in order of increasing ionization energy. Remember, increasing. So we are supposed to start with the radiation that has the lowest ionization energy. We know that gamma has the lowest ionization energy. So 2 starts, 2 less than, followed by beta, that's less than 3, and then lastly by alpha. Gamma has the lowest ionization, followed by beta, and the highest ionization energy is possessed by alpha particles. So the correct one is 2. That's gamma, followed by beta 3, and then finally alpha, which is 1. So the correct option is option C. Don't forget, the question could be twisted around and you could be asked to arrange them in increasing order of their penetrating power. Out of the 3 of them, gamma ray has the highest penetrating power, followed by beta ray, and followed by beta particle, and then lastly, the one that has the lowest penetrating power is alpha particle. So if you are to arrange these 3 radiations in increasing order of their penetrating power, we are supposed to have started with, we'll be starting with alpha particle. It has the lowest penetrating power. It can be absorbed by a thin sheet of paper. After that, we go to beta particle. Beta particle can pass through a thin sheet of paper, but it can easily be absorbed by an aluminum foil. And then lastly, gamma ray has the highest penetrating power because of its very short wavelength. Gamma ray can be absorbed by a thick block of lead. So, but for the purpose of this question, the correct answer is C. The one that has the lowest ionizing energy is gamma ray, followed by beta, and finally alpha. Correct option C. Let's go to number 27. Gamma rays are produced when, if you look at all the options, the correct option here is B. Gamma rays are always produced whenever there are changes within the nuclei being the plural of nucleus, of atoms. Whenever changes occur in the energy composition in the nuclei of atoms, gamma rays are emitted or produced. The correct option for number 27 is B. Let's go to number 28. When the direction of vibration of the particles of a medium is perpendicular to the direction of propagation of a wave, the wave is said to be, that's option B, transverse. Whenever the direction or propagation, remember the direction of propagation of the wave is perpendicular to the vibration of the particles of the medium, we refer to such a wave as transverse wave. So the correct answer is B. Let's go to number 29. A hunter fires a gun at a point 408 meter away from a cliff. He hears an echo 2.4 seconds later. We are to determine the speed of the sound wave. Let's take a look at the board. We have been given the distance. That's x. That's 408 meters. We have also been given the time the echo was at, which is 2.4 seconds. Then we are to find what the speed will be. We don't know. But we remember the famous formula for this. V is equal to 2x all over t, or 2d all over t. You can use x in place of d. It doesn't matter for the distance. V is the velocity velocity of the speed that we want to calculate here. So we've known our x to be 408. That's 2 times 408 divided by the time the echo was at. That's 2.4. Don't forget the unit is meter per second. So our V now becomes, so if you use our calculator, that's 2 times 408. That gives us 816. 816 divided by 2.4 meters per second. And if you divide this divided by 2.4, that gives us 340. That's 340 meters per second. And if you look at the board, that is option A. Okay, so As you can see, the correct answer is A, 340 meter per second. Let's go to number 30, please. The distance between the fixed points of a mercury in glass thermometer is 30 centimeters. We are to determine the temperature when the mercury level is 10.5 centimeters above the lower fixed point. Let's look at the board and see how we can do this. If these are the two fixed points, this is the upper fixed point, which is 100 degrees Celsius. And then this is the lower fixed point, 0 degrees Celsius. And don't forget, this is the highest point, the upper fixed point, and this is the lower fixed point. And we are told that the distance, let's take a look at the question. It says that the distance between the upper fixed point and the lower fixed point is 30 centimeters. So, which means if this one is 0 centimeters, then this one is 30 centimeters. That's what it means. Now, we are to determine the temperature. We want to determine the temperature. Let's say the temperature here, T degree Celsius. When the mercury level is 10.5 centimeters above the lower fixed point. This is the lower fixed point. So the temperature here, 10.5 centimeters. What do we do? Very simple. Here we now have 100. That will be 100, that's the upper fixed point, minus the lower fixed point, which is 0, divided by, then here, which is T minus 0. T minus 0 is equal to, then 30 minus 0, that's 30, minus 0, divided by, then 10.5, which is corresponding to the thing here. 10.5 minus 0. That's 10.5 minus 0. So 100 minus 0 gives us 100 all over T minus 0. Also gives us T is equal to 30 minus 0. That's 30 all over 10.5 minus 0. That's 10.5. What do we do? You can first multiply so that T times 30, that's 30T, is equal to 100 times 10.5, that's 1050. What do we do? Let's divide both sides by 30. So we now have our T, that the temperature is equal to, using our calculator. If you use a calculator, this is 1050 divided by 30. That gives us 35. That's 35 degrees Celsius. So the correct answer is option C, 35 degrees Celsius. Let's go to number 31. Which of the following statements about electromagnetic waves is not correct? If you look at this, they carry energy as they travel through space. That is correct. They travel with the speed of light, which is 3 times 10 raised to the power 8 meters per second. That is also correct. They are longitudinal. That is the statement that is incorrect, because all electromagnetic waves are transverse waves, not longitudinal. So the statement that is incorrect about electromagnetic wave here is they are longitudinal. They aren't longitudinal. They are not longitudinal. They are transverse in nature. The correct answer is option C. Let's go to number 32. The diameter of a brass ring at 30 degrees Celsius is 50 centimeters. To what temperature must this ring be heated to increase its diameter to 50.29 centimeters? And we have been given the linear expansivity of brass to be 1.9 times 10 to the power minus 5 per Kelvin. Let's look at the board and see how we can calculate this. This question is on expansion. So we'll be given the original diameter. Original diameter D1, that's 50 centimeters. We'll be given D2. When it is heated, diameter increases to 50.29 centimeters. The initial temperature, when the diameter is D1, that's theta 1, will be given to be 30 degrees Celsius. then we are asked at what temperature or to what temperature must this particular ring be heated so that the diameter increases to this. That's theta 2. We don't know that, unknown. And we know our linear expansivity, which is alpha, to be linear expansivity of brass 1.9 times 10 to the power minus 5 per Kelvin. Don't forget the popular formula. Linear expansivity is equal to, that's going to be L2 minus L1 all over L1, then change in temperature. Don't forget, change in temperature can also be written as theta 2 minus theta 1. I think we should do that. Theta 2 minus theta 1. But since we're talking about diameter here, we are not going to make use of L. We just change our L here to D so that this one becomes D1 minus D2. If we do that, then we have D2 and then D1. Remember, what I'm looking for is theta 2. We have been given our linear expansivity to be this. Let's substitute it, 1.9 times 10 to the power minus 5 as given in the question, all over 1 is equal to our D2. That's 50.29 minus D1, that's 50, divided by D1. We've forgotten to change this one to D1. That's D1, that's also 50. Then times our theta 2, what we have to calculate, minus the initial temperature, that is 30. So the next thing we do is 1.9 times 10 to the power minus 5 over 1 is equal to, if we subtract this, that should give us 0.29, I think, 50.29 minus 50. That's right, 0.29 all over 50 into theta 2 minus 30. What do we do next? We can simply cross multiply. If you cross multiply, then we now have this times this. That's going to be 1.9 times 10 to the power minus 5 times 50 into theta 2 minus 30 is equal to 1 times 0.29. That's 0.29. So if you multiply 1.9 times 10 to the power minus 5 by 50, what do we get? That's 1.9 times 10 to the power minus 5 times 50. That gives us 0.30095 into theta 2 minus 30 is equal to 0.29. So if you continue here, because of the limited space that we have, if you continue here, we cannot divide both sides. If we divide both sides by 0.00095 and this one divided by 0.00095, this will cancel this, and then we are left with theta 2 minus 30 is equal to, if we divide this, what will they give us? 0.29 divided by 0.0095. That gives us 305. Let's see. 305.26. What do we do? We take 30 to the opposite side. So theta 2 now becomes 305.26 plus 30. And then our theta 2 now becomes, that's plus 30. That gives us 335.26 degrees. So this is the correct answer. And if you look at this, it was corrected to 1 decimal place, and we can do that here. So our theta 2 here now becomes 335 points here. That's going to be 3 degrees Celsius. So the correct answer is option D. Number 33. Which of the following concepts is a method of heat transfer that does not require a material medium? The correct answer is definitely D. Conduction requires a material medium. Diffusion does require a material medium, so also does convection. But radiation does not require a material medium. It is through radiation that the heat from the sun reaches the Earth's surface. So the correct answer is D. Radiation does not require a material medium. Let's go to number 34. The engine of a car provides a forward force of 1,240 Newton, and the total resistive force, that's talking about the frictional force, on the car is 800 Newton. If the mass of the car is 1,220 kilograms, we are to determine the distance the car has to travel from rest before acquiring a speed of 4 meters per second. Let's look at the board and see how we can calculate this. So a car, the engine of the car provides a forward force of this. Forward force. The forward force is 1,240 Newton, and the resistive force, let's represent the forward force by F, and the resistive force by F, R. And the resistive force is what? Resistive force is 800 Newton. What do we do now? We calculate the net force acting on this particular engine. The net force now, that's going to be the forward force minus the resistive force. So the net force, let's represent F by net force, that's FF minus FR. So we are using F for the net force, FF for the forward force, and FR for the resistive force. So our net force gives us the forward force 1,240 Newton minus the resistive force, that's 800 Newton. So the net force now gives us, if we subtract this, 1240 minus 800, that gives us 440 Newton. That's 440 Newton. Now this is the force, this is the net force acting on this particular engine. Next, let's calculate the acceleration. We know that the net force, that's the net force, is equal to ma. And what is our m? That's the mass of the engine. And we are told the mass of the car, is 1,220 kilograms. We've calculated our net force to be 440 Newton. So that will be 440 Newton is equal to the mass, which is this, 1,220 times a. That's acceleration. And then our acceleration now is 440 divided by 1,220. And the unit of acceleration, don't forget, is meter per second squared. So our a now is, if we divided by 1,220, that gives us 0.36 meter per second squared. Now this is our acceleration. But remember, we are asked to determine the distance the car has to travel from rest. If the car is traveling from rest, it means the initial velocity is u, which is equal to 0. Before acquiring a speed of 4 meters per second, it means if it's starting from rest, u is equal to 0, and this particular 4 meters per second now is the final speed, which is v. Remember one of the equations of motion, v squared is equal to u squared plus 2as. V, that's the final velocity. In this case, that's our 4. That's 4 squared is equal to u squared. We know it is starting from rest, so that is 0. Then plus 2 times acceleration, we just calculated it to be 0.36 rather. Then times s, that is the distance that the question expects us to calculate. 4 squared is 16 is equal to, so 2 times this gives us 0.72 s. What do we do? Let's divide both sides by 0.72 so that our s now is equal to 16 divided by 0.72. 16 divided by 0.72. And that gives us 22.22 meters. And the correct answer is option B, 22.2 meter. Let's go to number 35. Number 35 now. A quantity of water at 0 degrees Celsius is heated to 30 degrees Celsius. For each degree rise in temperature, its density will dash. A. Rise steadily. B. Fall steadily. C. Fall and then rises. And D. Rise and then falls. First sense falls, we're talking about water. And don't forget that water exhibits or behaves anomalously between the temperature range of 0 degrees Celsius to 4 degrees Celsius. So, when water is being heated from 0 degrees Celsius, when it reaches 4 degrees Celsius, what happens? It's going to have its highest density. Don't forget that water has its highest density at 4 degrees Celsius. So when the quantity of this water is heated from 0 degrees Celsius, when it reaches 4 degrees Celsius, it's going to have or attain its highest density. But immediately above that 4 degrees Celsius, on the way to being heated to 30 degrees Celsius, what happens? The density now gradually begins to decrease. So the correct answer here will be it rises. When you're heating the water from 0 degrees Celsius, before it reaches the 4 degrees Celsius, it begins to rise and then it reaches the maximum density at 4 degrees Celsius. But after 4 degrees Celsius, the density begins to decrease. So the density first of all rises and then it falls. So the correct option is D. Let's go to number 36. A small object, number 35 rather, a small object of mass 50 grams is released from a point A. We are to determine the velocity of the object when it reaches a point B, a vertical distance of 30 meters below A. Let's look at the board and see how we can do this. Okay, a small object of mass 50 grams. The mass of the object, M, is 50 grams. If you convert this to kilogram, that will be 50 divided by 1000 kilogram here. So our mass now will be 0.05 kilogram. Not only that, we are told that this object of mass 50 grams is released, and we are to determine the velocity when it reaches a point 30 meters below. So when h is 30 meters below, what will be the velocity? Don't forget, they're asking us to calculate the final velocity. How do we know that? Because the object is released from a point prior to the release of the object is at rest. So which means the initial velocity of the object prior to its release is 0. I want to calculate what the velocity will be at a point 30 meters below. So we make use of our famous formula, V squared is equal to U squared plus 2GS. Or we can say 2GH since we've used H here. Remember, the S and H can be used interchangeably. Remember, when an object is released, it falls under gravity. That is why we are making use of acceleration due to gravity. And we'll be asked to take it to be 10 meters per second squared. So V squared is equal to, since it's released from rest, U is equal to 0. So U squared becomes 0 plus 2 times G. That's 10 times the height. That's 30 according to the question. So V squared is equal to 2 times 10. That's 20. 20 times 30. That's 600. If you take the square root of both sides, then V now is square root of 600. Let's find out from a calculator. What do we get? Square root, the square root. The square root of 600. That's 24.49. 24.49 meters per second. And if you look at the board, That is going to be option D. It was collected to 1 decimal place. That's 24. You can round this one to 0.5 meter per second. The correct answer is option D. Let's go to number 36. The viscosity of a fluid depends on the following factors except the... If you take a look at the option, the correct answer is the normal reaction in the fluid. As a matter of fact, that is one of the differences between solid friction and viscosity. Whereas solid friction depends on the normal reaction, viscosity, that's talking about the frictional force in a fluid. A fluid can either be a gas or a liquid. So viscosity of a fluid is independent. It does not depend on the normal reaction. So the viscosity of a fluid depends on the following factors except the correct answer is D, normal reaction. Viscosity does not depend on the normal reaction of a fluid. Don't forget, solid friction, on the other hand, does depend on the normal reaction. The correct answer, once again, for number 36 is D. Let's go to number 37. Using vernier calipers, which of the following readings gives the correct measurement for the length of a rod? We know that vernier calipers usually give is readings to 2 decimal places. So which of the options here is the reading given to 2 decimal places? That is option B. So for number 37, option B is the correct answer. Don't forget that vernier calipers can be used to measure things like the internal diameter of a test tube, for example. So the correct answer is option B. Number 38 now. The basic principle of operation of a beam balance is D, principle of moment. Don't forget, a beam balance is used in measuring what? That is the mass of a substance of an object, whereas a spring balance is used in measuring the weight of an object. So beam balance is used in measuring the mass of an object, and the principle is based on the principle of moment of forces, option D. Number 39. In which of the following situations is friction not useful? A, operation of a grinding machine. We know friction is very useful in the operation of a grinding machine. B, walking. Of course, friction prevents us from easily slipping and falling due to the excessive smoothness on the floor, as the case may be. C, application of brake. Of course, friction enables cars to stop when brakes are applied. And the correct option, moving of piston in a sleeve. This is the one that is not an application of a friction. The correct answer for this question is option D. Number 40 now. Which of the following quantities is not an example of a force? Tension is an example of a force, is measured in Newton. Weight is an example of a force, is also measured in Newton. Friction is an example of a force, even we refer to it as a frictional force. Mass, on the other hand, is not a quantity that is an example of a force. So for number 40, the correct answer is A. Hello students, I trust you've been enjoying the class. Please don't forget to subscribe and hit the notification bell so that you'll be notified whenever a new content is uploaded. And don't also forget to like, to share, and to leave us a comment. Thank you very much.